introduce. Are you ready? Okay. You good? All right. All right, awesome. Good afternoon. First of all, I want to say my name is Luther Hill. It's my first time at ConVerge. I want to thank the B-Sides community, the ConVerge community for inviting me out here. So I think it's my first time at ConVerge, and I think it's so far it's been an amazing experience, really amazing experience. So my talk today is on automating web app security in the AWS cloud environment. The basic principles we talk about today could really be applied to any type of cloud environment, but I picked AWS so we can take a look at how it's laid out as AWS has it. Find me on Twitter at WarEagle0, and the reason I have 0 on there is it's 0 indexed. So some guy basically had WarEagle1, I don't know why. So I figure but in coding, WarEagle0 is actually the very first one. So I am, as of right now on Twitter, the very first WarEagle. Go Auburn. Yes, I'm the very first WarEagle on Twitter. So this is me, just some basic information. I kind of split my time between Charlotte, North Carolina, Louisville, Kentucky, and Detroit, Michigan. I have a bachelor's of science in accounting. So I'm constantly giving people tax advice that they don't want or they don't need, apparently. Constantly doing that. I'm currently enrolled in about 3/4 of the way done with a master's of science in information assurance. And then I figured that wasn't enough, so I started a bachelor's of science in computer science. So information assurance master's, bachelor's of science, computer science. I'm an Army veteran. I don't know, I told people I used to blow stuff up and shoot guns. Now, I sit behind a desk all day. So it's a good change of pace. So this is the basic agenda. A couple things we're going to cover is, first off, we're going to talk about some 3 basic cloud truths. This is true as far as it relates to the cloud. We're going to cover the basic cloud architecture we're going to be setting up today, so you can kind of see what all of the rules and whatnot will look like. We're going to talk about the threats and how we're going to stop those threats with solutions, and at the end I'll take some basic questions. So who here has any kind of cloud environment? Web apps? We got a couple. Okay, so everybody's doing something in the cloud. All right. So I like this quote because I think it applies to so many things in life. The problem really isn't the problem, it's your attitude about the problem. In the world of security, InfoSec, there's a lot of challenges. We have constant challenges. Stuff is constantly changing. We have cloud, we have hybrid, we have on-prem, you got serverless. Things are just in constant flux and constantly changing. I want to challenge you to be problem solvers in your organization. Don't take the reactive approach. A lot of people tend to do that. I want you to take the proactive approach and think about how can I use my skill set and my tools to deliver the best solution to my customers. So first off, cloud truth. Anybody want to take a guess about, those are only 3 of them. Anybody want to take a guess to what the 3 cloud truths are? And keep in mind, I made these up, so if you guess them, that's really impressive. No? Okay, I didn't think so. So first one, that's what it is. I mean, that's really all it really is. Everybody, there's like everybody wants to give it a fancy name, a fancy thing, this, that. But at the end of the day, it's just somebody else's computer that you're using. That's it. If you're using Amazon, you're using Google, Dropbox, or whatever, it's just somebody else's computer. You're renting time, space, computing power on that computer. Now, different platforms allow different services. On AWS specifically, what I'll be focused on, they allow you to run Linux and Windows. I had a very interesting talk with some Mac people. There's no Mac on the cloud as of right now, I guess until Mac spins out their own cloud service. The other thing too is that the AWS cloud, just think of it as a virtualized platform. That's essentially what it is. It's hardware that's been virtualized so multiple people can use it. That's the next thing, right? In a lot of traditional IT settings, we are trained to look at what? The very first thing we're trained to look at, number one, when you're evaluating or troubleshooting a problem is everything connected? Is the hardware, are the lights blinking? Is it making noise? Is it spinning? Is it plugged in? In the cloud, we can't necessarily do that. In a cloud environment, the hardware is the software. That is what you are dealing with. So we have to get away from the mindset that, okay, there's a blinking light somewhere that I have to look at. There's a power button I have to push. No, it is code. The minute you start thinking about a cloud environment as one big code, the more effective you will be. The cloud environment is run on APIs. So that's it. Every button you push, every command you execute, it is an API call to the Amazon backend. So once you wrap your head around that, you will become a lot more effective working in that environment and stop treating your hardware like hardware and treat it like what it is, which is a piece of code that you're interacting with through an API call. And I like to say that developers really are the future of where cloud and cloud security is going, because once again, you don't have hardware, you have software. And what's software? Software is the playground of developers. So we really have to get as security practitioners better at implementing software-based security solutions. The other thing, security is still your responsibility. So everybody, the minute executives talk about, I want to do this in the cloud, I want to run this over here, I want to do this, I want to do that, people automatically assume that means you offload your risk responsibility. Somebody else takes on the risk, something happens, it's Amazon's fault, it's Google's fault, it's Microsoft's fault, but that is not the case. All cloud providers operate on a shared risk responsibility model, meaning that they are responsible, they assume the risk of the physical hardware. So if it's in the data center, if it's, if it has to physically plug in, if the power, the water, they assume the risk and cost of that. But you are still left with the risk of patching your systems, implementing proper firewall controls, making sure that access and authentication is done properly, all those different things. So you are still responsible for patching your systems. Amazon, Google, Microsoft, they will not patch your systems for you in the cloud. You are responsible for that. So we're going to just cover some basic architectural pieces that we're going to be using during this talk. So starting on the left and then moving right, we have the API gateway, which is a way of interacting with the Amazon cloud to do API calls. And same thing, like I said before, everything is an API call. So everything gets logged, which is the beauty of operating in the cloud. Everything you ever do will get logged. From the most mundane to the most complex, there is a log of it somewhere residing in the cloud, and it is kept. Second thing, this is in particular what we're going to be working with, the web application firewall. It allows you to set rules to block malicious traffic and different things going on with your applications you have hosted in the cloud. So, and God bless the vendors out there. Some great people, but one of the solutions that I came across yesterday was, I want to say like don't quote me on the cost, but from what I heard is about $20,000, all-in-one solution, web app firewall, router and everything, everything hosted in the cloud. Hey, you can set up rules, you can block traffic and do all that stuff. And I'm listening to the spiel because I love a good sales pitch. I used to work in the sales kind of recruiting background. So I love a good sales pitch. And, honestly, if the pitch is good, I might just buy it anyway, even if I don't need it, just because I respect the work that went into it. I appreciate the work. And I'm hearing it, and then I asked him a very basic question, which is, so how is this better than the web app firewall at Amazon? And his response to me was, there's a web app firewall on Amazon? I'm like, yes, and it's free, because if you have an AWS account, it comes with it, and it's free. And as far as I could tell, their solution definitely looked better. Don't get me wrong. It was very fancy looking, great color scheme, very intuitive. But at the end of the day, it was no better than what Amazon has provided to you for free with your account. The last thing on here is Lambda. So Lambda really, I had a great, interesting conversation with someone yesterday. And the point was that he made was that Lambda is the ultimate fulfillment of the cloud promise. Lambda allows you to forget all about the server, forget about the network, forget about what platform you're running in. You can just push code, Python, C, C++, whatever, maybe even assembly, who knows. You can push code directly to Amazon and they will run it. You don't have to tell them what server, what this, what that. Nope. Send them code and they will execute that code for you and take the action that code says. So that's Lambda. A couple other things. So we have CloudFront. CloudFront allows you to push your hosting and your hosting resources as close as possible to the end user. AWS is global in scope and scale. So you have data centers east, west coast, you have South America, you have Europe, you have Australia is one, you have in China and Singapore. So we all serve global customers. We can't say where a customer is going to come from. And obviously we're all working to reduce latency, right? We want the web apps to load as quickly as possible, be right there when the customer needs it. So CloudFront allows you to take whatever web app you're working with, keep it within the Amazon network, but host it as close as possible to where the customer is. So the customer's in Europe, you can set up a CloudFront instance of that web app in Europe that's cached there, so they don't have to keep coming all the way back to the East Coast or the West Coast to get the data. They can get the data right there in Europe with the same permissions and everything else as every other instance you have. CloudWatch does monitoring. I had a good question yesterday, which is, it's so hard to get the logs in Amazon. Like, where are they at? Everybody, there's all these logs, but I can't find them. CloudWatch is the place where you would find them at. It allows you to keep the logs anywhere from 14 days to 15 months. After that, you will have to pipe it over into an S3, some from an S3 bucket, either S3 bucket or like a Glacier bucket that's more long-term and cost-effective. But if you don't set any logging parameters, then your logs will disappear after a set number of days. Because everything is an API call, everything can get logged. Also, the logs can go anywhere from a minute to an hour. You can space how you want your logs done. And then last up, we have the application load balancer. So in keeping with the hardware is the software theme, the application load balancer allows you to intelligently route traffic based on rules that you've set and defined. So if you want a certain IP address to go to the West Coast, it'll go there. If you want it to go to China, it'll go there, or however you want to distribute your traffic. So this is the basic infrastructure that we're going to create using the rules and different things we're going to talk about. The threats that we're going to block are bot scrapers, the common stuff based on OWASP Top 10 2017, in addition to Amazon Best Security Practices for January 2018. So simple things, cross-site scripting, known attacker protection, whitelist, blacklist. So as you can tell, it's real basic architecture. It just calls a couple of Lambda functions that you upload to do certain actions based on criteria that you've set. All right, so this is my crazy threat picture. This is really what I feel like security is a lot of times. You have that door, and then just some crazy person at the door, like sticking his head through, trying to just get you, and you constantly like pushing against that door, like I just got to keep this door so they can't get in. So first thing we're going to do, they're broken down into groups of 3. So first kind of topics we're going to cover is bots. So you have malicious bots, web scrapers. So maybe you have information from your website you don't want web scrapers to find. LinkedIn does this, and a few other places does this. SQL injections is always a big thing. Cross-site scripting is also a big thing. And a big part of this push is so that we can have defense in depth. A lot of us focus on the development part, making sure that the web apps and whatnot are in accordance with those things. So we want the developers to script it out and, do all that stuff. As security practitioners, we can add another layer of security by implementing those same things into the firewall. So you have 2 layers of security. So the developer forgets it, at least it's right there at their front door stopping it. So the basic situation is this. You have a public web app, it's publicly facing, and then it has to trust unknown clients. You don't really know who's connecting to it. You're just it's hanging out there for people to interact with. Other thing is you have some form of input on your web app, right? They can enter an email address, their height, name, whatever it is that calls some kind of SQL code in the back. So, and you might also be open to cross-site scripting. Who knows? So this is a basic SQL query that you might be open to. So what the attacker here is looking for is just a basic, ID parameter from an SQL database. Who knows what they're trying to find on there? So this is an example of an cross-site scripting attack. You have a basic script that redirects to a malicious website. They might be posted in the comments. It could be anywhere where it allows the person to write in information. So instead of loading your website, now it's going to load a malicious website. So first solution we're going to implement, and I'll talk about how and you'll see on the diagram where exactly this gets implemented. But this right here is a basic rule that you can implement in your script to create a honeypot. What the honeypot does, it solves the bot scraper problem on this simple premise. In your robots.txt, you're going to have a list of websites, that's open. You're going to have disallowed, don't scan this. If that website gets scanned, you can assume that that's a malicious actor. You can assume that, okay, I told you not to scan it, you still scanned it, so that's a malicious actor. What this does, and let me go to the next slide. What this does, it creates this basic architectural framework where it gets scanned, right? The Lambda function that you've implemented along with the gateway results, it gets pushed back to your wireless access firewall, your web access firewall, and it updates that IP address in there to say, hey, this is a malicious actor. Why? Because they scanned something I told them not to scan. So you don't have to actually have any data on there. It's not really anything crazy you're doing. You're just saying, here's a bad website. Everybody, good person they won't scan it. Respect the rules. Malicious actors, they don't care. They'll scan it. You'll get a copy of the email, their IP address. It'll trigger a code set in Lambda, update your firewall, and that IP address is now blocked. And that's the great thing about the cloud environments, is that it allows you to automate it through code. Because once again, you're not dealing with the hardware, you are dealing with code. You can push these things as code. You don't have to go in there and log in and okay, I gotta do this, I gotta do that. No, create a Python script, save it in Lambda, and it's just done automatically without you even worrying about it. So it's really, really powerful on that aspect. The other thing, let me go back real quick. So on the cross-site scripting and everything, you'll see how we kind of solve for that in a second here. But yeah, so this is the basic kind of architecture you're going to be creating by implementing that solution. So the solution is, in all my slides, I'll push them out on Twitter. Amazon, let me see if I can click on it in here. So this is a live demo, so forgive me if this does not work. Cannot locate. Oh, no internet. Okay, never mind. All right, so anyway, we'll skip that. So the link I have here, and you can see the reference. I can push the slide deck out to anybody who wants it. But Amazon has already created this as a JSON application or a JSON code. So none of this stuff is things that you're going to have to create yourself, because I don't create it myself. If you go to the Amazon code base on GitHub, on web automation security, the entire JSON code is there. All you have to do is implement your particular details on the firewall, what websites you want blocked, what your honeypot is going to be, and you can roll that entire thing out as code, as a JSON code. So you don't have to, and I got to script this whole thing out. It's already done for you. And all the links I have on here will take you directly to that code base in GitHub. So this is essentially what you're doing when you're creating the firewall rules itself, or the code pushes those firewall rules. You're matching different queries against different things. So if you've identified a particular SQL, the way they write the SQLs, you can code it, say, okay, block these particular, strings or whatever it is. Block all of this so nobody can access it. So it really gives you a good granular control over what's going on in your web app. You don't have to worry about, oh my God, did the developer forget it? Is it a legacy code base? Did I update it this weekend? You can block all of those things on the front end by simply putting what parameters you want into the web application firewall. Same thing here, you can also block cross-site scripting, because just remember, it's all text that they're typing into the web app. So if it goes into the web app, it goes through the firewall. If it goes through the firewall, you can block it if you know what to look for. So you're no longer chasing down loose ends, it is completely automated front end, not dependent on whatever code is written on the back end. The web application firewall is doing it for you. So scan and list, this is similar to the bad bots, but sometimes maybe you're out there on a network and you have your stuff hanging out there and people are just scanning. You're constantly getting pinged, or maybe you have a list of known bad actors, right? You have a list within your company you keep of IP addresses that these are the bad guys. These are the people that I do not want on accessing anything in my network whatsoever. So the basic situation is, malicious probes, scanning, whatnot is taking place in your network. You're trying to figure out a way to block it, right? Or your organization might buy a list, have a list, or however you acquire the list of known bad IP addresses. So these are some initial websites you can go onto and find a common list of known bad IP addresses. So this is not every single bad IP address, but it's a good starting point. You obviously have Tor nodes that might be malicious. You have emerging threats. Maybe, APT1 is using a known IP address. You can automatically block for that versus having to, I don't know what their IP address is and you don't know it's malicious till they attack you, then you're blocking it. This way, there's a known list of malicious IPs, and you are creating functions to scan that first before traffic is allowed. So this is the basic architecture that you're creating, right? The load balancer or the CloudFront, they're going to keep track of what IP addresses are visiting your website. Remember, we talked about CloudWatch. CloudWatch does not permanently store your log records. To permanently store your log records, you have to create an S3 bucket or a Glacier instance that will store that. Once your logs are stored, it just becomes a searchable database like everything else. That's where we have the Lambda. The Lambda code that is also linked in here will parse through that list of IP addresses, right? It'll parse through the list of IP addresses. It will check whatever websites against a known bad list of bad actors, either you create or you download from a website. It will check that, and if it finds any of those bad actors, it will block that traffic in the web app firewall. So once again, you've automated your whitelist, blacklist in your web application firewall before the traffic really has a chance to go through your network. Now, this obviously doesn't solve every single problem, but it solves the common problem of, I know they're bad, I have a list of them, I keep a very detailed list of who's good, who's bad, but how do I programmatically implement that in my firewall? How do I make that automatic? How do I run that as code? And that's what this solves. So this is a link, once again, to the GitHub repository for AWS. Download the code, run it into your system, and it'll take care of it for you automatically. So this is another known vulnerability or what's going on. You have attackers, you have DDoS, you have HTTP floods coming into your system, and you're trying to block it. It's very similar to the known bad actors. So like we talked about, you've identified known bad actors, right? So similar thing, you have a list, or maybe you've created your own list of what's going on. So you're trying to figure out, okay, I know who's malicious. I know what's going on. How do I fix it? So this is an example of an exit node that Tor does. So if you look at it, you'll see there's an IP address. There's a date when it accessed the information. It has a lot of really good information. So all this information in here, same thing. If you let a Lambda function, which is a server or whatnot, call it, you can run it as script and automate your security. And that's really the key thing I'm trying to come across here, is that you want to automate your security. You don't want to, you want to have minimal personal involvement in your security. Why? Because when your web apps are in the cloud or just hosted really anywhere, they're going to get a lot of traffic. You could be that person dealing with it at 2 o'clock in the morning, or you could just let a piece of Python code do the exact same thing you would do at 2 o'clock in the morning. So this is the architecture that we would create, right? We would have our load balancer or CloudFront. You'd have the Amazon CloudWatch event. It would generate like, hey, this is going on. You have your Lambda function parsing through the list of IP addresses. Your Lambda function would send that out to a third-party IP reputation list. They would it would match it or not match it. Then it would kick back like, okay, it's a known attacker or not a known attacker. Same thing, it would update your web application firewall so that it automatically blocks, or I don't know, maybe you could set like a really nasty message for them, like, don't come here anymore. You can also see who's generating errors. So attackers, a common technique is they will send a misformed package to your site that will generate like a known HTTP error. So they'll get HTTP 403, whatever it is. You can set up a CloudWatch event or a firewall event to watch for that specific response. So maybe you don't have a list of bad actors. Maybe that one didn't show up, but you notice on your log traffic that there's one IP address that keeps sending malformed packets that generate HTTP errors. Now, typically, you would have to go through, parse the log, take a look at it, kind of evaluate it, and then figure out, okay, it's a bad actor, let me block this website. You can automate that process through implementing code that does the exact same thing. Why? Because those logs are already stored. So you parse the log with code, whatever code you want to write, C++, C, Python, Node.js. You look at that log, you say, okay, this IP address keeps doing an error. We're going to block it, or we're not going to block it. You can also set a threshold. Maybe your website is just kind of buggy, and maybe it kicks off those errors every now and then. So, okay, 1 error, not that bad. 2 errors, not that bad. But maybe there's somebody doing 100 errors. You're like, okay, there's no way my website is kicking back 100 HTTP errors. This has to be somebody looking for a vulnerability, looking for something that is not right. So same thing, you can rate limit what you want that piece of code to do, and it will automatically do it for you. So yeah, this is the same thing. I'm going to turn on my hotspot and see if we're going to have a little bit of time, connect to the GitHub repository for this, and then show you some of the actual code that AWS has implemented. So yeah, list parser. So by doing these basic steps, you've at the end of the day implemented this architecture into your AWS system. it's easy, or it's easier than buying a $20,000 web application firewall. If you're handy with code, you can do it all by JSON and just pushing it to the API gateway to update all of your settings. If you're not handy with JSON, you can log into your actual AWS account and go through, just pick whatever firewall you're messing with, and you can go through and just click through it and do the exact same thing. So it's relatively easy to set up. It just involves going in there and doing it and screening out whatever criteria that you're looking for. So same thing on the presentation. It's going to have, these are all the references I use, including the links. So you have the OWASP Top 10 for 2017, has some really good stuff in there. AWS white papers. In my personal opinion, I think AWS puts out some of the most concise white papers out there. Google, they kind of like, their version of help desk, not to knock the Google guys, is Google it. That's the Google help desk, Google it. Azure is good as well, but AWS by far, from my experience, keeps the most updated documentation. Whether or not their product is any better than anybody else's, that's for argument, but documentation-wise, they have some really, really great stuff. So there's a link on there for the AWS GitHub with all of the code that we talked about that you can push to your API and implement yourself. You don't need me, you don't need anybody, it's all out there. There's also the AWS Security and Automation Guide that walks you through the exact steps you need to take, how to set IP, how to do this, how to do that in your web application firewall. So if you wanted to go back and really look at how to do it, that maybe the slides weren't enough, they were too generic for you, you can pull up all of those links and step by step follow through how to do it. And I think I have internet, so I'm going to see if I can connect and pull up some actual code for you. All right. Ooh. Ooh. Oh, what am I doing? Control. All right, let's see. All right, maybe the demo gods will be, oh, there we go. We have code. All right, so clicking through. Yeah, so everything I have on here is accessible as code. Let's just go to the reputation list one. I don't know if I can view it. Yep, so there you go. Everything is in there. So, I mean, you can go through and kind of set it up how you want to, whatever dependencies, whatever websites. So, I mean, it's really, really good. Like I said, a lot. That's what I like about Amazon in particular. They have a lot of really free information and good documentation that you can go through, implement different solutions that they recommend. They have their own architectural framework they want you to implement and run. So it's a good way to kind of, I know they want me to run this, but what resources are available? What code do I need? How do I do this? How do I do that? So all of that stuff is right there for you. And it's open source, so you can also contribute to it. If you find something that is not quite right or you want to improve on, you can send some GitHub so you can push the code and, get some amazing credit. All right. Okay, so go back here. All right, so I'm going to open it up. We've got a couple minutes for any questions, comments, concerns. Anybody have anything? No? Okay, then I got something for you then. If you don't have anything for me, I got something for you. So, who here has implemented some kind of security solution in their cloud? 1, 2, 3. Okay, so you have a cloud and you're implemented a security solution. Do you follow any particular guide? Like I'm following, the CIS, I'm following OWASP, I'm following whatever, or you just kind of like rolling your own security out there? What are we doing? You in the back, sir.
We do a shitload of government work, so we follow a bunch of the NIST guidelines.
NIST guidelines? Okay. Yeah, I had to read, one of my classes, I had to read the NIST publication. It really put me to sleep. That thing really, and it was funny because the class I had to, talk about was configuration management. So that was even worse because it was very dry. But some good information in there. I like the incident response plan, the way they do it. So what about you? What kind of security are you rolling out?
We have a WAF deployed in the cloud. We follow the OWASP, and then a little bit of our own security guidelines mixed in.
Okay, so you have your own security and you also follow OWASP. That is very good. Anybody in here using Microsoft Azure as your cloud solutions provider? No? Anybody using AWS as your cloud solutions provider? Okay, 1. Kind of. Google Cloud. Anybody using Google Cloud? I have 2s. All right. So that's about what is going on out there, because if you look at the statistics, Amazon has the biggest market share. Azure has the fastest growth rate, and Google Cloud is the dirt cheap, alternative. A lot of my developer friends tend to use Google Cloud. They say it's easy to implement, it's real developer friendly. So that's something for it. But as far as the web application firewall, I'm pretty sure that you can implement the same thing across different platforms. The exact buttons you will have to click will differ, but the solutions are still the same. Because the important thing to remember is the hardware is the software. It's just code. It is an API call that gets logged that you can then run a function on, parse it, pull out information, and take an automatic action. It does not really require user involvement. If you set it up properly, it could be run automatically. And it's really great for those of us who follow a defense in-depth model. Why? Because you can set protection at different layers of the organization, right? You want web application, you want your developers to do some stuff, you want access control list. You can set a lot of different layers of protection, because we all know we don't want one single point of failure. We don't want security to be the sole SQL injection to be the sole responsibility of the developers. We want to make sure that we cover those in multiple ways across multiple platforms. And the other important thing I want everybody to remember as far as the cloud, go back to the cloud truths, which is really, this is the truest statement ever about the cloud. It is just somebody else's computer. That is all it is. It's not, magic pixie dust that you can sprinkle on like every application and be like, it's running in the cloud now, it's so much better. No, it is just somebody else's computer. So a couple takeaways and things to remember that I want to kind of leave you with is that, in my experience, when people roll out a cloud solution, whether it be security or whatever it is, they tend to treat it like it's the exact same physical server that they have in their basement. They have my server in my basement is spun up 24/7. I want my cloud server to be spun up 24/7. I have a Cisco router. I want a Cisco router in the cloud. I have this, I want that. So the great thing about a cloud environment or a virtualized environment is that it allows you to develop a responsive environment. So because the cloud is essentially just code, that's all it is, it's just code that's running on somebody else's computer, you can make that environment responsive. So if you wanted to say, 9 to 5, I need a solid 10 gigs of bandwidth, I need, 5 terabytes of hard drive space because that is what my users need during the day. That is just what I need to get business done. They're going to charge you, $100 for it. So, okay, it'll cost you $100. Now you have to ask yourself from a business case perspective, do you need the same thing after 6 p.m. when everybody's gone? No, you don't. You don't need the exact same thing. Maybe really all you need is, I just need 1 gig of throughput, bandwidth in case anybody's logging on. I maybe need 1 terabyte of hard drive space because, nobody's really doing anything on that. You can build that in to your cloud architecture and make it responsive. So that is the great thing about a cloud environment. It doesn't solve all your problems. I personally believe that we're moving more towards a hybrid environment. I could see a hybrid environment being a lot more effective in certain instances. Some people and some companies I know, especially at the startup level, everything's in the cloud. Everything in the cloud. But there will come a point in time where it might be more cost effective to have it on site. So I'm not opposed to having stuff on site. I really believe that in most cases, a hybrid solution is probably the way you want to go because there's benefits to having stuff on site. There's benefits to having stuff in the cloud. So, I don't want to get too focused in one lane about this is the only way to do it. So any other questions?
Yeah, because CSP, through ICS squared, realistically, that's the biggest fallacy. It's really that you can think that email is the cloud. Just someone else's computer to want scalability. You have that scalability, and then you can have the cloud.
Yeah. No, that's a good point. Scalability. So there's like three things that Amazon really, when they talk about their environment, really focuses on is reliability, elasticity, and I think scalability. So reliability is basically saying, 5 nines uptime, it'll be available when you want it, where you want it. So that's reliability. Scalability, meaning that if you need 10 gigs, it'll give you 10 gigs. Elasticity, meaning that if you need to shrink it down to 1 gig, you can shrink it down to 1 gig. That doesn't change the underlying software you're running. It'll still run Linux. It'll still do everything you need it to do. But the cost can be fluctuated based on what you need. A great way of thinking about it is if you wanted to run this CloudWatch like an IP whitelist, blacklist type application, about 10 million API calls to that will only cost you about $5. So unless you're doing something drastically bigger than 10 million API calls, implement that type of solution on your website will, cost you about $5. For $5, I think that's a pretty good return on investment when you talk about what you're blocking and everything else. So with that, I am going to end it. If you have any more questions or anything, feel free to follow up with me afterwards. Once again, find me on Twitter at War Eagle. And last comment for the day, go Auburn!